That's it. We'll share the screen. And sorry. Right. Can you see the screen on the online session? Can you actually hear me? Can you hear me in the online session? Hello? Can somebody say something?
We can hear you.
I'm sorry, can you say something again?
We can hear you, Professor.
Well, we can't hear you, unfortunately. Can you confirm that you hear us? Kind of need to write it in the chat. Sorry, we're facing a little bit of problem. Let me move to the slides that we want to talk about. For some reason, the chat is also not working. So maybe I should just log in from here. Can you guys actually hear me now? Okay. Sorry? All right. Okay, so the problem is so last time we were talking about yeah, this is not going to work out. Okay, you should be hearing me now still. So last time we were talking about this data set that we've been using for a week, and we wanted to recreate this graph. that was coming from that source. I don't remember where it was published. Let me see. So it was economics data, and it had an HDI rank, an HDI and a CPI, and a region and a country. So we wanted to recreate this graph as an example for ggplot. So we started with some basic things. The basic things that we've done the whole session the other week was we created a ggplot structure that used CPI for X and use HDI for I and color for region. When we did that, we get the graph like that. And all of these items that you see on the screen on left, if we fix then an address, then we are gonna convert this simple graph to that complex graph that we saw in that magazine. So then we started first with putting with adding the trend line. Now, in order to add this trend line, we did something unusual, and that was after we loaded the ggplot2 data structure, then we added a smooth line, and then on top of that, we called that whole thing a PC2, and then on top of that, we added a GeoM point layer, which basically allows all the points to be placed on top of the line rather than being obscured by the line. In the next step was to convert these points that we've got to these type of points, which are larger, bigger, and not filled. So we needed to figure out how to recreate this. And we knew that we have to use a shape, but the question was which shape? So in order to deal with this, we started to practice with it. So we created a dummy data frame that has X and Y and Z. Z is going to be the values of 1 to 25, and these values are actually the values that if you send to a shape, then it will basically create something unusual for you. Some sort of symbol, put some sort of symbol on the screen. So X and Y are going to be the location of those symbols. So we use ggplot to create this data structure for plotting, setting aesthetics with X equal X and Y equal Y, return that to S. And then the outcome was S plus GeoM point, with the shape being equal to Z in aesthetic. And we set the size to 4, and we add the scale shape identity in here. This resulted in what we see on the screen. Now, there are multiple candidates in here. One of them is going to be this one that can possibly represent those points that we saw in that graph, and the other one is this one. But there is still possible that convert some of these to those as well. So the next step was to basically color code this. So we color code this thing, and these two are still some useful candidates, and the field version is also quite interesting. It might become handy. So we did this by setting color to red. Remember, if the option or the parameters that you want to set, you're setting it with a single value, with a fixed value, then you cannot set this to aesthetic. The example of that is setting size to 4 and color to red. Color is going to be red for all the shapes, and size is going to be 4 for all the shapes. But when we want to set the shape itself, there are multiple shapes inside there, right? So every entry is going to have its own shape there. So because of that, then we have to set shape to aesthetic. So when we did that, we get these three are the possible candidates in here. these two might also become interesting if you can change the size and so on. Then the next one is we next one that we need to do is to also fill the input. So now that we are filling it, then it seems like this one is likely to be the correct answer. So we are going to use this in our plot. So now we are going to redraw this by incorporating that shape into here. So this means that the value in here for this shape is 1. So we just, instead of just saying geo point, now we set the geo point with 1 and size to 4. So this is going to give us an open circle, similar to what we were looking for. But the problem is the size of the line around the point is much narrower compared to the actual original graph, if you compare it with this one. So now we have to deal with that a little bit. So in order to deal with that, we basically set the size to 2.5. And we are also setting the stroke to 1.25. Now it's giving us that nice effect that we wanted. But by doing so, we also have problems in here that we have to deal with later on. So the next step in here was to basically put the labels. I put these two graphs side by side so you can see how things are coming along. So this is going to be a little bit tricky because there is no attribute in the data that separates points that should be labeled from points that should not be labeled. So the first step to do is to identify these points. So in here, we did a bit simple thing. We looked at this graph and realized that these are the labels that we need. So we just created a vector that has all the labels that we want. Then we have our PC3, and now we are adding a geom text into it with the aesthetics of label equal country, and the color being gray 20. But in the data, we are putting a filter. The filter that we are putting is going to get rid of everything that we don't want it and just put the labels for those that we wanted. Those that we wanted are these, right? I cannot directly print these on the screen because if I want to do, then I need to know the exact X and Y location. But X and Y locations are already in the ggplot, right? So we already have those. If I can just filter out everything that I don't want to print label on and just keep those that I want to print on with the geom text, then I'm done, right? So the way that I'm doing it in here is we're using a filter. We're saying the data is coming from that. Within the field of country, which is also being used for labeling in here. Within this field, only use the data points that are within the points to label, which are going to be these points. So for all those points that we need a label, it's going to put the label on their X and Y locations. For everything else, it's just going to ignore them. Because those labels does not include, are not present in this points to label vector that we created for ourselves. So when we do this, it's going to create this graphical display that we see. This is more or less gets the information across, but then the labels are kind of overlapping. And what we have to do now is we have to use a ggRepl package to basically solve this problem for ourselves. At the end of the day, if you want a perfect answer, you probably have to do some hands-on, hand adjustment to this. But ggRepl would probably bring us very close to what we want. So we want to solve these issues that we see in here. And issues around here. So we are using geom_text REPL instead, because we are getting this from the ggRepl library. So everything else is the same. We force a 10-point separation between them, so it will automatically find a better place for it. So it kind of solves our problem in some degree. It's still not as in terms of the way that the labels are presented, but at least the labels are in correct location now, and they are not overlapping each other. So we still have to deal with the legend in here. This is not the type of legend that we want. So things are starting to come together. There are just a couple of more things we need to add, and then all that is going to be left at the end is going to be just to play around with the theme of this graph. We are going to have it. So comparing our graph to the original, the labels and the orders of the regions in the color legend are quite different from each other. So we have to fix this now. To correct this, we need to both change the labels and also the order of the regions that we've got there. So in order to do this, we are using a factor. So we're going to use a factor function in here. We are setting the that region column, and using the factor, we said the data is coming from that region. There are going to be levels. These levels are the labels that we see right now, and but the labels are going to be changed to this. Now, when we construct the plot using these data, the order should basically appear as it does in the original graph. So it starts to look like this. Now we can see that we've got multiple lines in here on some of the lengthier legends that we had. And the order is also now corrected. So it from this, we now came to this. So now the next step is going to be to add the titles and format the axes. We do that using the scale system in ggplot2. So we are using a scale continuous and setting the label in here. And then a scale while continuous. And at the end, we are using the scale color manual, which would basically set the color codings the way that we want them. Now these colors are looking much closer And at the end, we also added the GG title. That would basically give us this title in here. So we added the Y title, or the Y axis label, the X axis label, and this other title, and we also fixed our color codings of those cycles that we've got. Now the last step is going to be to fix the themes. So we need to adjust some of the theme elements and label the axes and legends. And this part basically usually involves some trial and error in order for you to basically figure out where things need to be positioned. But the way that we did it in here is we started with a minimal theme, and then we added another theme on top of that, where we set the text to a text color of gray 20. Then we set the legends by setting the position on top, changing the legend direction to horizontal, and doing the legend justification, setting it to 0.1, which is going to anchor the point for the legend position, and then setting the legend text to element text with size of 11 and color of gray 10, which is giving us this effect that is exactly what we had on the original plot. Then we are setting the axis. We are setting the font in the text to italic. In the axis title X, we are setting we are basically moving the title away from the axis, and we are doing the same thing for the Y axis by setting the element text. And then we are also resetting the element text, the axis tick Y. We're resetting the ticks to element blank, so getting rid of the ticks. Then after this, we are setting the axis line to element line with the color of gray 20 and size of 0.5, and axis line Y we are resetting it with element blank. Then we are introducing a panel grid major with element line of gray 50 and size of 0.5, and at the end we are setting the X in that major to element blank, and we get the same graph that we started with. We could have still played with the Y-axis a little bit more. There is still a little bit of effect that you can see in here. And there is still some of these X-axis. There are some effect there that can be removed, but it's quite close. Any question on this one? How much time do we have? Awesome. All right. So now I want to do this thing. No? Where is it? Where did I put this in? Here it is. Okay. No, actually, hold on. Sorry, I keep confusing myself between two different computers. Okay, let me share the screen. Actually, let me change this thing. Okay, now you see my screen, and now let me share a screen with the online group. Can you guys see the screen? Awesome. Okay. So I prepared 2 hands-on sessions. You start with the first one today and see how far we go. You can probably hopefully finish it. This is quite small and it's quite easy. I don't think there's going to be that much of a problem. But then we've got another one after this that we can do on Wednesday. I already uploaded these files in Canvas. So you can basically look at them there. And somebody taught me last time how to change the font size. It was in View. Nope. That's not it. Okay. I think it was somewhere in preference or something. Does anybody remember?
You try to zoom in on the it's like third down.
This one?
Yeah, I can try that.
Okay, that's okay. Okay. All right. So all the links to this material are already here. If you were interested to go and see them, but we are starting with basically loading the ggplot2 library, and then we are going to use a dataset called Titanic. And I'm loading it up in here. So Titanic is a dataset that has information about 891 observation with 12 variables. So it has information about the passengers and who survived and who didn't, which class they were on, what was their names, their sex, their age. I'm assuming this is sibling. I've got no clue what is this purchase, their ticket, their fare, their cabin, and their embark. So this is about the Titanic ship. So now we are going to set up some factors. So we are going to start playing around with this Titanic P class, which has values between 1 and 3. And we're going to convert this to a factor. So when we do that, if you look at this, then it's going to give us a levels of 1, 2, and 3. Before it didn't give us any level. The other one that we're going to look at is the survived. This is either 0 or 1, meaning either they survived or not. We are going to convert this to a factor as well. And when we look at it, it's going to have 2 levels of 0 and 1 again. The next one is going to be the sex. and it's going to be male and female. And the embark, it has C, Q, and S levels. Now we are going to start our visual analysis of the data, focusing on questions related to survival rates. So specifically, those questions will use the factor, meaning categorical variables in the data. Factor data is very common in the business context, and ggplot2 offers many powerful features for visualizing factor data. So the first question that we want to answer is, what was the survival rate? So survived is a factor right now, so we can use a bar chart to generate it. So we are going to use a ggplot saying the data is Titanic, then use aesthetics to set the X equal to survive, and then add a geom bar to it. When we do that, we are going to get this. And if we want to convert this to percent, then we can basically use a table function. And when you use the table function, it gives you the numbers for group 0 and the numbers for group 1. And then convert that to a proportional table, which is going to be this 0.61% on death and 0.38% on survival. Now we are going to replot this, adding BW10 to it, and adding a geom bar to it, and also adding some labels to it, which set the y-axis to passenger count and the title to Titanic survival rates. So when I run this, it's going to add this passenger count in the y label. The x label already has survived. It's coming from this. Whatever the name of the variable is, it's going to use that as the name that it puts there. So it's very important when you're programming in R to use proper variable names. Otherwise, your graphs requires extra steps in order to create the correct names. And then it also added this this graph title for us on top of here. Then the second question that we want to answer in this data set is that what was the survival rate by gender? So obviously what we need to do is we need to use basically use a different aesthetic. We are going to set the X to 6 and fill it with survived. So when everything else is kind of the same thing, but when I do this, it's going to give me a slightly different type of bar. Now X is 6, so I'm either going to have female or male in here, but this is going to be a field with the survived data. So it's going to have, each bar is going to have 2 bar plots on top of each other. The next question that we can answer is, what was the survival rate by class of ticket? If we wanted to do that, then we can basically set the X aesthetic to PC class. We want to know the survived by the class of ticket, and then fill it with survived. So when we do that, this graph is going to be converted to this version. Now we've got 3 classes because our P class became a factor with 3 levels of 1, 2, 3. So we've got 3 classes in here, and we're filling it with survived on a bar graph. So it's going to give us this effect that you're seeing here. The next question that we want to be able to answer is, what was the survival rate by class of ticket gender? So we need to, again, set it up with x equal to 6 and fill it with survived again. But we also need to set the facet wrap. So we're going to use the facet to further segment the data and enable visual drill down into the data. So when we do that, everything else is the same, but the effect that we are going to get is this. So we are going to have 3 sets of bar plots, each one of them associated to a particular P class, because we use the facet wrap in here. And then within each of these, we've got bar plots that are based on sex and is filled with the survived. So it seems like majority of the females in group 1, in class 1, are survived, and like something like 1/3 of males, or a little bit more, probably 1/3. 1/3 of males in the first class are also saved. In the second class, majority of the females, like 95%, are saved, but a very, very low percentage of males are saved. And in the third class, it seems like half of the females are saved, and very small portion of males are saved. But it's also noticeable that there are lots of males in the third class. Any questions? No? It's the tilde would basically says that this is going to be done by P class. Okay, so it's separation by P class. Okay, so it's going to look at the levels of the P class. Remember, we deliberately convert the P class to a factor, because ggplot would offer a lot of functionality when your data is of a specific type, and factor is one of those types. Okay, otherwise, if we didn't want to do this, then we had to, for example, if we wanted to do this to a base graphic, what we had to do was do a group file. Okay, so use a group file to basically put them in different groups, or use a filter to put them in different groups, and then plot them one by one. Okay, but in here, you can basically convert your data to a factor, and then use that as an advantage, using a facet wrap to basically create group-wise representation of what is happening. Okay. So next, we will move to visualize the continuous data using ggplot2. We will explore visualizations of single numeric variables like columns, and also illustrate how ggplot2 enables visual drill down on numeric data. So the question that we want to answer in here is, what is the distribution of passenger ages? So the moment that it talks about distribution, we have to develop some histograms. Okay, so we've got the ggplot. The Titanic is going to be the name of the data set, or where the data is, the variable that holds the data. And we are setting the aesthetic to age. And then we are adding a geom histogram on it. And there is nothing special about this, really. That's it. A very simplistic thing. The next question that we want to answer in here is, what are the survival rates by age? So again, because it's by age, then the x-axis are going to become age, and we are going to fill it with survived. And then the type of the graph is going to be a histogram. So this would give us a histogram like this. What this bit in here does is basically setting up all the labels for you. You can say set my Y label to this and X-axis label to that and the actual title to this in one go, in one layer. It will set everything. Otherwise, you could use that scaling function or scaling layers that you saw on the previous examples with what was the data set that we were using? HDI and CPI, I think. I forgot what was the name of the data, but anyhow. So the next one is we can actually visualize this through a box and whisker plot. So everything else is the same, except that now we set the X to survive and Y to age. And instead of using a geom histogram, we actually use a box plot. When we do that, then we get this. Which is quite uninformative, but you know. So the seventh question, and I think this is the last one, yeah. The seventh question is, what is the survival rates by age when segmented by gender and class of tickets? So instead of using a histogram, we could actually use a density plot. You can think of a density plot as a smoothed version of a histogram. And we can use facets to allow for visual drill down within the density. So we want to know what is the survival rate by age, and we wanted to segment by gender and class tickets. So we start with creating the data structure. We call ggplot. The data is going to be Titanic. The assets, the aesthetics are going to be set to X being age and filled by survival. Then we are adding a simple theme of PW to it. We are setting the facet wrap to be 6 by P class. And we are using a geom density and then some labels. When we do that, we get this effect. So first, because we set 6 by P class, then it automatically groups things to two groups of female and male. Within female and male, then it's going to group them in three classes of class 1, class 2, and class T on the basis of P class levels. And then within that, it's going to draw a density plot that captures the survived and unsurvived ones. Make sense? Everyone understand this? If I ask you to plot something, are you going to use ggplot or base graph? ggplot. It's very addictive. I've never seen anybody who used ggplot to ever try to touch base graph, unless they just want to create a histogram or just a scatter plot, just a plot. If it is anything beyond saying plot or hist, they are not going to touch it because ggplot is very, very easier structurally to basically put it together. Now, if you wanted to do this with histogram, you could basically replace this line with a histogram, with the geom histogram. And if you were to do that, then this whole thing would have looked like this. Any questions? Yes.
Did it automatically remove or not plot anything
I don't think we had any NA in that data set.
When I initially looked at it, I thought I saw some NA. Like, I'm wondering
Let's take a
what
look
that
at it.
warning message is.
On which one?
There's a warning message that you're doing 177 rows and thinking,
But
finite
there's
value.
one, row
Yeah,
number
there's
6 on
NA,
this page.
so what is it doing?
Row what? 600 what?
H is the column, but row 6 was specifically just blank there.
Row
But
6.
there's a bunch of H. Like, we get-
H. Yes, you're right. There are some NAs. It's just ignoring them.
Okay, I was just wondering.
No, it's automatically ignoring them.
Is that just a feature of GD5? Just we'll ignore those rows?
It's not necessarily a good feature. Because, no, seriously, you don't want, we're going to see this in the second hands-on session. You don't want your graphic display to decide how to display it. Okay? You have to decide how things are going to be displayed on the basis of the way the data is. Okay? Now, right now, I've got no clue how did it basically fill up that NA. Is it a mean? Is it a median? Is it just a 0? Is it just a 1? Is it randomly picking a number and putting it there? It can be anything, right? And that's not how things are going to work in data science. So in the next hands-on session, we are going to do this instead of answering some questions, as it was in that session with I'm not sure what it was, Dojo something, or Dojo. Let me see. Data Science Dojo. And instead of this approach, the other one that we are going to do is focus on data science aspect of it. So it goes step by step with the goal of creating some sort of machine learning predictions on the data. But a good chunk of it is data visualization and how to prepare the data. And it basically step by step deals with every single abnormality within data before you even start to use machine learning. But we actually use data visualization and histograms and so on to figure out if there is something wrong with the data before you actually do anything else. Okay? There isn't going to be enough time to finish that one. That at least takes 1 hour, if not more. So we have to go through that on next session. Is there any questions? Yes.
Is the model that we're going to use next time the linear mixed models that we talked about?
No. We are going to do linear regression a little bit and a little bit of random forest, I think, from memory. But really, those parts are not important. The important part in here is just the ggplot side of it and how we can use data visualization to fix our data before doing any statistical analysis. Okay? So after the next session on Wednesday, then from next week, first of all, I'm going to release homework 3. And then from next week, we are going to be a split again. One class is going to be, each week is going to be on theory side, and one class is going to be on linear mixed model. And my hope is by mid-November, when we are going to have a break, we are done with linear mixed model completely. It should not take more than 2 sessions, maybe with the hands-on session, maybe about 3 maximum. So in 3 weeks, we should be done with that. And we can release the homework 4 and the final homework. And when we come back from the break, you are only going to have the final project to do. Assuming that by now you guys started to look at Tableau. If you haven't done so, you're going to get into trouble. So seriously, start with the Tableau right away. You're losing time. It's not going to be that straightforward. Is there any questions? No? Is this any helpful, or do you rather if I don't do hands-on sessions?
Wow, that's very helpful.
Okay, so the code is already uploaded. You can take a look. As I said before, there are many of these online. You can just do a Google search and you can find like 20 of these. Okay, I picked the ones that are a little bit different from what we did in the past. So you can see some different capabilities of ggplot2. But there are so many of these that you can do. So my advice is, if you really want to learn this, and I really hope that you do, go and do some search. Get a couple of these examples, there are many of them, and just run them and see how it works, and try to figure out the mechanism inside it. Okay? Thanks a lot, everyone. See you guys on Wednesday.